I'm just going to explain how to diagnose any faults with the Mini-Weld Model 6 or Mini-Weld Model 7 airless plastic welders. They're a real simple tool. Other than the power cords, there's really only two components that can go bad that will cause it to stop working. And both are easily checked using a multimeter and just by measuring the ohms. The most common thing is the heating element inside the airless welder goes bad. That's a part that looks like this on the Mini-Weld Model 7. On the Model 6, it's a nichrome wire wrapped around a spool. So you can't just replace the core, you have to replace the whole cable and everything. The easiest way to do this is just to open up the box here and make sure it's unplugged. You don't want to have your cords plugged into anything. And I'll unplug that, get it out of the way. And you're going to use just a small Phillips head screwdriver to unscrew the tiny, tiny screw on the side of the box. All right, so with that screw, open the control box. And in here you'll see there's a control switch and then just some electrical connectors. So basically what we're going to do is check the continuity of the circuit from the blue wire that goes to the heating element and the white wire, or well, in this case it's gray, that goes to the switch. Sometimes you'll find that these are black and white. It doesn't really matter, same component. The easiest way to get these apart, just kind of wiggle sideways and pull. They are pretty tight. I'm going to use those pliers here, unplug this. And this one actually doesn't have to come completely off. You just have to get some metal exposed on the tab. But the wire to the switch does need to be disassembled. Like that. All right, so I'm going to take a multimeter. It's set on ohms. All right, so ohms is the little upside down horseshoe, and that's just testing resistance through the circuit. You're gonna test the heating element only because there is a capacitor in the switch that won't allow you to get an accurate reading through the switch. On the Mini-Weld Model 7, you should get about 53 ohms plus or minus 3. If it's a little bit out of that range, don't worry about it. It'll still work. If it's not showing any continuity, of course, then it'll be a bad heating element or a bad wire. Okay, so I've got this set on ohms. I should also mention on the Model 6 welder, it'll be about 176 ohms. All right, so I'm just going to take one contact and put it on the tab right there. All right. And then I'm going to take the other one and I'm going to put it on the tab here. All right. So you see this welder is not showing any continuity through that circuit. So what that tells me is that there's something between here and the heating element that would cause this not to work. All right. So in order to replace the heating element, and also you can double check the heating element in here, you're just going to unscrew this large nut. And you can usually do that by hand. Just unscrews like that. Pull that off. Pull your little spacer out. And then we're going to remove the 3 screws here. And you could use the same screwdriver. Okay, once you have those 3 screws out, you just remove that. And then in here you've got a ground spring. Okay, so what you can do is you can push the cord and everything up through the handle. And the ground spring, it just plugs in. There's a little tiny connector there. Just unplug that, slide that off. And then your heating element just pulls out like that. And so you can see this one's been used. I'll double check this just to make sure it's not something else. So I'll put the contacts on the heating element. And so I've got 54.2 ohms. Okay, so what that's telling me is that, you know, the fault in this is somewhere in here, or it was just a loose connection. And that does sometimes happen. You can also see that this is twisted. This will happen if somebody tries tightening the tip without holding the flats of the heating element. So it can spin it around, and that can actually cause a short sometimes. So I'm going to untwist that. And actually, I think I found the fault. You've got this connector here that is not fully seated inside the housing. So I'm going to push that in. And it's snug now. Yeah, all I'm going to do is reconnect that. Slide this insulator back down. All right, I'm going to slide this spring back on, reconnect it. So that's your basic assembly. I'm just going to pull it back down through the handle. And this ground spring is just used to make contact with the metal part here, and that grounds the whole thing in case you have a short. All right, so while I'm doing this, I'm going to talk about the switch. And, you know, if you were to do a continuity check through the switch, depending on the position of the switch, sometimes it'll show continuity, sometimes it won't. You'll get kind of a random resistance reading, and it really doesn't tell you whether the switch is good or bad. So to determine if the switch is bad, you know, you're just going to rule out the heating element. If the heating element's good, the wire checks out good, then you know it's the switch. All right, so I've got those 3 screws in. Reinstall the spacer here. Take my welding tip, put that back on, and this kind of fits down in over the element inside. Keep that from turning. Take some pliers and just give it a little snugging up. And there we go. Just going to double check my continuity at the box again. And we're getting 54.7 ohms. So that loose wire in the handle is the fault. And I'm just going to reconnect this. Put the lid back on the box. But in case this, you know, say it was the switch is pretty easy to replace. It's just 2 contacts. You pull the knob straight off. There's a nut there. You just unscrew the nut, pull the switch out, put the new one back in, and put your knob back on. And get that sealed up. And put your plug back on. And there you have it.